गुड इवनिंग, कैसे हैं आप? आज हम लोग बात करने वाले हैं हाइड्रोजन स्पेक्ट्रा, स्पेसिफिकली अब्जॉर्प्शन एंड एमिशन स्पेक्ट्रा, दोनों की बात करने वाले हैं. नाउ आई हैव ऑलरेडी गिवन यू आइडियाज अबाउट दिस इन माय फर्स्ट सेशन. दिस इज द फोर्थ सेशन, पार्ट 4 ऑफ दिस सीरीज. और फर्स्ट सेशन में आई थिंक आई स्पेंड अबाउट 5-7 मिनट्स ऑन इट. एंड इनफैक्ट जो लास्ट सेशन था, विच वाज पार्ट 3, उसमें हमने बोर मॉडल की बात की. तो एक एक्सटेंशन ही समझ लीजिए बोर मॉडल का इन हाइड्रोजन स्पेक्ट्रा. ठीक है, एनर्जी वेवलेंथ के आइडियाज जो वहां से पढ़े थे, वी विल जस्ट यूज इट हियर. एनर्जी की बात की थी, वेवलेंथ हमने पहले सेशन में बात की थी. ठीक है, सो एज ऑलवेज व्हाट वील डू इज एनसीईआरटी खोल के देखते हैं कि वेयर आर वी एट, राइट, इन एनसीईआरटी, बिकॉज दैट इज आवर guide to figure out JEE, NEET, and all these exams. Are you able to hear me and see me clearly? Please let me know in the chat. All right, all right, all right, all right. Hold on. NCRT kholi jaye. And khul ja sim sim. Oops, that worked. Task failed successfully. Yeah, it's weird. When I minimize the window, it decides to not show up. रुको, कहाँ गया ये? Here it is. Here it is right now. Okay, great. So the things I've ticked, ये हम लोग ऑलरेडी कर चुके हैं, और आज हम लोग पार्ट 4 करने वाले हैं, which is the features of atomic spectra. यहाँ पे बस एक लाइन लिखी है, but it's actually quite interesting and it keeps being asked. Oh, by the way, did you guys see the JEE advanced paper? Maybe you did, maybe you did not. बट जो मैंने बोर में आपको लास्ट क्लास में सिखाया था, उससे डायरेक्टली आप JEE एडवांस का पेपर कर सकते हो. आई एम नॉट किडिंग. स्टिक अराउंड फॉर सम टाइम, आई विल शो यू दैट क्वेश्चन एज वेल. अब एक दो सवाल शुरू करिए, एंड I'll show you from my PPT over there कि bro same question आया JEE advanced में. So it's very cool. Okay, all this has been removed from your syllabus. Yeah, the first part atomic structure का सब हट गया है. What is actually there, Thomson model, ये सब नहीं है. ये सब भी नहीं है in your syllabus right now, whether you're doing JEE or NEET. Hey Mike, how you doing? So let's skip that. It's okay. Part 4 में हम लोग है ना. Let's scroll all the way. ये सब we have done, we have done, we have done, we have done, we have done all of this. और हम लोग क्या करेंगे अब? Line spectrum. हाँ, see this is what our focus is. Okay. So you're gonna focus on the line spectrum of hydrogen. मैंने आपको बताया था कि emission happens from a hot gas, और एक specific कुछ लाइंस ही एमिट होती हैं, एंड दैट वाज प्रूफ दैट एनर्जी इज क्वांटाइज्ड. ये था कॉन्टेक्स्ट. ये कॉन्टेक्स्ट मैंने आपको दिया था कि कैसे पता चला कि एनर्जी जो है एक पैकेट्स में ही निकलती है. तो हाइड्रोजन फॉर स्पेसिफिकली वो कुछ एनर्जी को ऑब्जॉर्ब करता है. इलेक्ट्रॉन्स गेट एक्साइटेड व्हेन दे फॉल डाउन, दे रिलीज सम सॉर्ट ऑफ रेडिएशन इन द फॉर्म ऑफ लाइट और इलेक्ट्रोमैग्नेटिक रेडिएशन. उसका वेवलेंथ जब निकालोगे तो एक स्पेसिफिक कुछ बैंड्स मिलते हैं. दैट वाज द एमिशन स्पेक्ट्रा. वी विल लुक एट इट इन डिटेल. ओके, here it is, emission spectra, right on top of my head. And absorption spectra, एक hot gas को ले लिया हमने. ठीक है, okay, sorry, not hot gas, this is the hot gas. Excited sample मतलब hot gas. I've written that this has hot gas in that, and I took cold gas over here, मतलब this absorbs. So cold gas absorbs these exact same lines जो emitted थी. So it's like the negative of this spectra right over here. It's very interesting. We'll go over all of this. और हाइड्रोजन के कौन से अलग अलग होते हैं उसी को हम लोग करेंगे. वी हैव इनफैक्ट डन द होल ऑफ बोर मॉडल. आई नो हमने थोड़ा उल्टा अप्रोच ले लिया, but I thought Bohr model was important to even understand what is going on in all these series, right? So we've done the Bohr model in detail. We'll do all these awesome counting of lines. So इसमें कुछ numerical heavy होगा ये session थोड़ा सा. So yeah, stay tuned, stay tuned. I'm great, thank you. Mohidul, all right, bro. You gotta keep trying, man. I mean, you gotta find a drive. For me, the drive is spiritual. You gotta find a drive that helps you study. Mohidul saying he's having trouble studying. He or she is having trouble studying. Anyway, let's get started. उसके बाद हम लोग करेंगे quantum stuff. We'll talk about De Broglie, Victor De Broglie, and awesome work that he did. Khair, let's talk about this right now. Let's start today's session. That's the focus, right? Hydrogen spectra. कौन सा? Absorption and emission both. That's what today is going to be all about. Yeah, I've been watching some Canadian YouTubers. थोड़े क्वेश्चन कर लेते हैं लास्ट सेशन से. मैं यू रेडी? या व्हाट इज द एनर्जी ऑफ ग्राउंड स्टेट ऑफ He प्लस आयन? He प्लस आयन का ग्राउंड स्टेट की एनर्जी क्या है? हाउ डू यू डू अ क्वेश्चन लाइक दिस? डू यू वांट हेल्प ऑन दिस? I think there's a direct way to do this, right? Energy is proportional to z square by n square. There were three things that we learned in the last session. R is proportional to n square by z, and we also learned that velocity is proportional to z by n, and hence energy is proportional to z square by n square. These are the three relations. In fact, V kind of gives you E, right? Because E is half m v square. So mass also is constant, whether it's electron, proton, or koi bhi other particle, right? So that's how you do this question. You have two things here. Now He plus is a single electron species, which means it behaves like hydrogen. So हम लोग ये expressions इसके लिए use कर सकते हैं. But the Z and the N values will change. Now remember, मैंने last time बताया था कि बोर के वर्क में थोड़ा बहुत complication तो था, right? A lot of things he said did not work out. Like why does it rotate, doesn't crash or not? That's fine, that's fine. But these ideas are still useful. These results are still useful. Hey, Pawan, good evening. How are you doing? Can you try this question out? Can you try this question out? So the general idea is that if you take an electron from infinite distance and you bring it really close to the nucleus, that's the ground state, right? उसकी एनर्जी क्या होगी? It will lose energy. This is important. बहुत जरूरी है कि lose energy, तो you get a negative number right over there. इस आइडिया से भी एक जेई एडवांस का सवाल हो सकता था. Really, I'm not kidding. Okay. So negative 13.6 in electron volts times z square by n square. You can also take it as 2.18 into 10 power minus 18 joule minus, right? Same चीज है. But since हम लोग electron volt की बात कर रहे हैं, let's do this. Okay. Negative 13.6 times z square by n square. Okay. That's it. Now what is z? Z is the atomic number. Hydrogen, helium. So helium का atomic number is 2. N is going to be 1. Hey folks, come on. Be a little active. Let me know what you think. See, if you are here, if you're watching this live, then it'll be good. It'll be good that you can hold on. I think YouTube is saying something. Huh? Not receiving enough video to smooth streaming. What does that even mean? YouTube is saying it's not receiving enough video to smooth streaming. Huh? I don't have any drop frames. Wow, this is weird, huh? Okay, hold on. Let me switch my internet up if this is behaving weird. Is my connection a little weird to you? Hold on. Let me switch it up very quickly. Give me a second. The help of the stream. Anyway, we're back up now. We're back up now. Are you able to see me and hear me now? Yeah. It may have been weird for a second. It's cool now. Yeah, just give me a thumbs up if you're able to see me and hear me now. I think the drop frame things would have stopped. It was really weird. Okay, now we're good. I think now we're good. It is good. Okay, cool. What is the energy of ground state of He plus ion? So n is 1, z is 2. Let's put that together and we get times z square by n. Z square is going to be equal to 4. 4 into 13.6 is negative 54.4. Be careful, it's not plus, it's negative. Okay. Any doubts on this question? Sorry about my internet. It's the first time this has ever happened. This is weird. Huh? I hope you guys are able to see me and hear me clearly now. No scene there, right? Okay, cool. How about another question? Ionization energy of He plus is 19.6 into 10 power minus 18 joule per atom. The energy of the first stationary state, n equal to 1, of Li2 plus is what? Oof, Li2 plus. Ionization energy of He plus कुछ दिया हुआ है. Energy of the first stationary state. Okay, what do we do here? First stationary state. Hey Pawan, Mohidul, Mehak, how are you doing? Are we going to try this question or it'll be good to have some inputs as well? And if you don't understand something, let me know. I'm here to help you out, to help you figure this out. All right, cool. So 19.6 into 10 power minus 18 joule is, it seems like it's काफी ज़्यादा, right? 2.18 was the base one. Okay, what does ionization energy mean anyway? Ionization energy का मतलब है कि उस इलेक्ट्रॉन, सबसे outermost इलेक्ट्रॉन को निकालना. Okay, outermost electron. Okay, so He plus becomes what? He plus has one electron. उसको it is becoming He2 plus. ठीक है, वो एक इलेक्ट्रॉन भी निकल गया. दो थे, एक निकाल दिया, He plus हो गया. दो मतलब सारे इलेक्ट्रॉन निकल गए. तो इसमें एक ही इलेक्ट्रॉन इसको हम लोग निकाल रहे हैं away from the atom. That's what this ionization energy is. So okay, the energy of the first stationary state n equal to 1 of Li2 plus is what? How do you do a question like this? See, in this question, E naught is not given. So maybe we know it, but we can also use this equation to figure it out, right? Again, definition of ionization energies, electron को orbit से लेके infinity में ले जाओ, ठीक है? Or not orbital, orbit. We are still talking orbits, KL, MN shells, okay? So energy of He plus, right? This ionization energy is going to be E naught, whatever the base energy is, times Z square by N square. मैंने same formula पहले use किया. Now for Li2 plus, that is again single electron system, okay? Single electron system. So I can use the same expression, but now Z value changes and becomes the same. Okay. So out of this is known. So let me write that down. ये यहाँ पे मुझे दिया हुआ है 19.6 into 10 power minus 18. Remember, there is no negative sign right now. This is really important. There is no negative sign. Why is there no negative sign? Negative sign तब आ रहा था जब आप इलेक्ट्रॉन को बहुत दूर से डाल रहे हो inside the atom. Now you're taking the electron from the atom and throwing it away. That means you have to provide energy. Think about it like this. It's a very oversimplified idea, right? To break a bond, you have to pull it apart. You have to provide energy. Break किसी भी चीज को तोड़ने के लिए उसको एनर्जी लानी पड़ती है. When a bond is formed, energy is released. But to pull apart the bond, you require to give energy. That's the general idea. Okay. So technically, in a way, theoretically, I know there's no bond being formed, but this is a crude way of remembering it. ठीक है? तो मैंने sort of electron को break away किया from the atom, right? So I require to give it energy. So that is a positive value. Okay. That's important. This positive, negative. Because देखो यहाँ पे जो signs है, positive, negative सब जगह है. That's also something you're going to have to keep in mind. Okay. So keeping that in mind, I get that E naught times this is this. I don't need the value of E naught, but I can find it out. If I get E naught from here, then I can substitute here and get this. That's what we're going to do. So I have basically substituted E naught to be this right now. This whole thing is E naught, this thing. How? Take 2 square to the other side. That's all. Okay, times 3 square. So it is 9 by 4 times 19.6, whatever that value is. 9 by 4 times this is 49. Yeah, 4.9 into 9, right? 19.6 by 2 square, which is basically 4, is going to be 4.9 into 9. Now, what is that value? मतलब 44 हो जाएगा, right? 45 हो जाएगा. 5 into 9 is 45. So, उससे थोड़ा कम. So, 44 हो जाएगा. ठीक है. 44 की दो वैल्यूज हैं यहाँ पे. Right? 4.4, 44, same thing. It's 10 power minus 18. Na? Make it 17. That's all. Okay, great. But here's the thing. 17 में एक ही answer है. This is it. This is 16. So, this is not the answer. See, this is 18. What is happening here? This is 44.1. Right? Okay. 44.1 है यहाँ पे. Now, here, you take this as 4.41. Right? And make it 10 power minus 17. Why? Let's take it like this. Let's write as 44.1. And I know the students have sometimes of trouble with this. Okay, that's why I'm writing those. Although it's a very, very straightforward step. 44.1 into 10 power minus 18. Multiply by 10, divide by 10. When you divide by 10, it becomes 44.1. Okay? Multiply by 10, matlab, this becomes plus 1. So that's how you get 4.41 into 10 power minus 17. Now this is interesting. देखो, ये energy value negative हो गया. The ionization energy was positive, but the actual energy, what is ionization energy? Pulling away of the electron. What is the energy of the first stationary state? Energy of a state is you take an electron from infinity and you put it into this. That is reduction in energy. इसलिए this value is going to be negative. This value is positive. ये बहुत जरूरी है and this will help build foundation for the whole of periodic table. So please इसको ध्यान से समझिए. ठीक है? Please understand this properly. It has to be seen. We spent a lot of time on these couple of questions, but it's okay. I think it's important to do it. All right, let's start talking about today's topic, right? Spectroscopy. It's the branch of chemistry that deals with, well, not really chemistry, science that deals with study of spectra. What is spectra? Electromagnetic spectra. हमने देखा था, right? I've spoken about that in the first session. And spectrometer is something that's used to separate the component into different अलग-अलग peaks, so to speak, जो detect करता है radiation of different wavelengths. Detect करता है wavelength of different radiations. Okay, cool. We can do that. So a spectrogram is a graph. It looks like this. It can have two ways. Yeah, it can look something like this, or it could look like this. Okay, there are two ways. Okay, this is important. This one is something. This one is something else. What do you think? Which one is which? Think about it. Toward the end, at the end of the class, you'll be able to figure out. One of them is the emission spectra, and the other one is the absorption. Now, which one is which? I've got 1 and 2. I want you to tell me this. Application of spectroscopy, art and music. It's a great question. When you do chemical bonding, when you do organic chemistry, infrared spectroscopy tells you what kind of bonds exist in a molecule. See, organic chemistry, you will see that there is multiple different bonds that carbon forms with things. Carbon oxygen के साथ single bond बनाता है, double bond बनाता है, और बहुत बहुत अतरंगी चीजें करता है, सिंगल बॉन्ड और एक और बहुत चीजें करता रहता है. ठीक है. सो कौन सा बॉन्ड है? नाइट्रोजन के साथ भी बॉन्ड बनाता है, एक बॉन्ड, डबल बॉन्ड बनाता है, ट्रिपल बॉन्ड, बहुत अलग अलग चीज बनाता है. ऑल ऑफ दीज हैव डिफरेंट frequencies at which they vibrate and all of that. उसको हम लोग कैलकुलेट कर सकते हैं using infrared spectroscopy, nuclear magnetic resonance, NMR spectroscopy, and all of that. It's a very cool question, Art. Thank you for asking me that question. Anyway, by the end of this session, you will be able to identify which of this is emission, which of these is absorption spectros. If you already know it, please tell me, let me know in the comments which one is which. Let's talk about emission spectroscopy in a little bit of detail. Okay. अगर कोई excited substance है, तो वो excited state से unexcited state, ground state पे गिर जाता है इलेक्ट्रॉन. When it does that, the energy has to be conserved. Where did that energy go? It goes away in the form of radiation. So you detect some peaks. Yeah, be some excited मैंने तुमको gas दे दी है. With time, those will fall down. Maybe it'll fall down 1 step, 2 step, 10 steps. We'll see. We'll see. What do I mean by fall down? What do I mean by steps? We'll see all of that. हम लोगों ने पढ़ा था emission spectrum to be continuous, right? Electromagnetic spectrum, it looks like this, but in reality, it looks like it's continuous. But when you talk about actual stuff in hydrogen and all that, it's actually discrete. इसका भी मैंने आपको idea. This was what led to the idea that भाई energy is quantized. Yeah, energy being quantized. Okay, we saw that when we heated say hydrogen or any other gas and we let it go through the prism, same cheese, but instead of this, now I take instead of a bulb, I take a hot gas and I do this exact same experiment. I will not get this. I will get some random lines. I will literally get some random lines like, भाई lines क्यों मिल रही है मुझे? So when you get discrete stuff, you get a line and you get a band. When you get a band, this is in higher energies, okay? Higher energy, and I'm not going to talk about this because it's a little bit heavy for you guys. Read up more about this later on. Higher energy and also multi-electron systems. ठीक है? अभी हम लोग सिर्फ बात कर रहे हैं single electron system की. This is important, okay? The band is basically many lines that come close together. That's a band, okay? ठीक है. So look at this. You get different lines. This is what the hydrogen spectrum looks like. This is what the hydrogen spectrum looks like. You got a red line, an orange line. The colors matter, okay? So this is the highest wavelength. And this is the lowest wavelength. Right? Which means कि ये है highest energy and hence frequency. And this is the lowest energy and frequency. ठीक है? ये सब समझ में आ रहा है ना? How? C equal to nu into lambda using the electromagnetic spectrum का idea itself. ठीक है? So now look at this. Gas in excited state, or in the first session मैंने बोला था, I call it a hot gas. You take a hot gas. Excited state मतलब मैंने गर्म कर दिया तो excited हो गया ना? If you increase the temperature, you're exciting stuff. It moves faster. ये तो हमने पहले lower grade में पढ़ा है. Now I'm saying by heating it up, you're also giving it enough energy to do this fancy thing. Okay. It gives you these lines. It doesn't give you a continuous spectrum, which is very interesting. And this is a way to fingerprint the gas itself. Gas मैंने बोला है, you need to convert it into a gas or a plasma state to be able to use this sort of spectroscopy technique. That's a small nuance of this. Okay. So it is formed like a fingerprint of this gas itself. So it's unique to each element and it identifies unknown atoms. That's why it's useful as art and music asked. Okay. Band कब बनता है? Interesting है ये चीज. ठीक है. हाँ. When it looks like this, it forms a band. Now this is a little bit complicated. ठीक है. And this happens when you have molecules and not atoms and not single electron systems. Okay? अगर आपको band दिख रहा है, not lines, okay, it's band. It's not just a red line, but a red band and all of that. ठीक है? So you have multi electrons, like मैंने आपको बताया ना, carbon monoxide, maybe you have CH3, you have other things. ठीक है? Some other कुछ और हो रहा है. ठीक है? All right. Now let's talk about absorption spectra. Emission समझ में आ गया, right? Which is why now if I were to go back to this graph जो मैंने draw किया था, right? If I plot wavelength over here, so this sort of a graph जहाँ peaks होती हैं, that is the emission spectra. मैंने बोला था this will be clear till the end of the session, but already पढ़ा दिया. ठीक है, चले. Okay. Absorption spectra में क्या होता है कि यार मैंने ठंडी गैस ले ली है, and between the prism and the light, I put that gas. Okay. So there are dark lines. Okay. In the continuous spectra. ये क्या मतलब हुआ? मतलब कि these are missing. Why are they missing? Because these got absorbed. These lines, specifically this got absorbed by a gas. You see? So पहले there is a light source, a regular white light. Let's call it white light. ये मैंने पहले सेशन में बताया था. And you have gas in the ground state. Let's say cold gas in this case, right? Depends on different books. They write different things. I know हम लोग NCERT वाला focus है, but let's learn this idea properly. ठीक है? Because if you go into science and engineering, or if you decide to do anything related to lab, you will spend a lot of time in your life doing this spectroscopy wala business. Oh, congratulations, game ki dunya. Congratulations. Art, those dark spaces are the exact same things जो hydrogen का absorption, sorry, हाइड्रोजन का जो एमिशन वाला था, नाउ इफ आई टॉक अबाउट ओनली अबाउट हाइड्रोजन, हाइड्रोजन का जो एमिशन वाली लाइंस थी वही चीज यहां पे अब्सॉर्ब हो गई है। अब्सॉर्ब क्यों हो गई है? बिकॉज इज द सेम थिंग यार, वो पहले एक्साइटेड स्टेट था, नाउ इसका ग्राफ कैसे लिखेगा दिखेगा, इट विल लुक लाइक दिस। सो आई हैव समथिंग गोइंग लाइक दिस बट सडनली गेट्स अब्सॉर्ब। दीज आर योर डार्क लाइंस, दीज आर द डार्क लाइंस, ठीक है। मैंने आपको बोला अलग अलग ग्राफ कौन सा होगा। सो दिस इज लैम्डा एंड दिस इज बेसिकली इंटेंसिटी ऑफ रेडिएशन। अगर विजिबल लाइट में दिख रहा है तो आपको ये कलर्स दिख जाएंगे, अगर इंफ्रारेड हो सकता है, यूवी हो सकता है, ठीक है, इट कुड बी एनीथिंग, इंटेंसिटी ऑफ एनी रेडिएशन, नॉट नेसेसरली जस्ट विजिबल। विजिबल तो बस आपको दिखाने के लिए, ठीक है, कूल। सो हियर व्हाट इज हैपनिंग, सी यू आर गिविंग इट सम एनर्जी एंड इट गेट्स ऊपर चला जाता है, ठीक है, एंड एज सून लूज एनर्जी कम्स बैक डाउन। इंटरेस्टिंगली वेलोसिटी ऊपर नीचे होती है, क्यों? वेलोसिटी इज प्रोपोर्शनल टू z by n। सो एज आई इंक्रीज द n वेलोसिटी फॉल्स। ये सब, ये एक जो छोटा सा एनिमेशन है, बहुत चीजें एक साथ साथ सिखा रहा है, बहुत चीजें साथ साथ दिखा रहा है। दैट्स कांग्रेट्स लूसी, गुड टू हियर, गुड टू हियर। ऑलराइट, थैंक्स गेम साहब। आर्ट you're good, okay, great, lovely, lovely। so this is the most beautiful thing। देखो दोनों को हम लोग साथ में बनाए तो you get the continuous spectra, you saw that। दोनों कौन से हैं? it's gonna come again, right? so those lines, those individual lines, these are the emission spectra, okay, by a hot or excited gas, okay, and the dark lines, the dark side, that is the absorption spectra. And if I add them both up, I get the continuous spectra. That is what this GIF is showing, right? I'll give you the notes of this session, but note में आपको ये सब नहीं दिखेगा, right? Which is why the live session. Okay, cool. Game साहब फिर से क्या repeat करें? Which part? Have you joined in just now? Please watch the last 10 minutes of my session. It will be clear. I've been explaining this for the last 10 minutes exactly 10 minutes में इसको explain कर रहा हूँ, ठीक है? The idea is there are two things happening. I take a hot, excited gas and I pass the emission from that through a prism. That gives me a spectrum which has lines, एक line, एक red line, एक orange line, all that. These lines pertain to the emission spectra of that species. In this case, could be hydrogen, could be anything. The other way is कि मैंने cold gas ली and I take a source of light. Light के बाद में रखता हूँ cold gas and then I pass that light through the prism. So there is some absorption that has happened between the gas, right? And that is what is shown by these, ये second वाली चीज. So नीचे the bottom part again is this and the top part is this, okay? Please just check the last 10 minutes of the session if you still have any doubts. I've also done part one. Game, I think you're new to this channel. Check out the part one of this session. I've also explained this, right? Okay, let's talk about hydrogen specifically. Hydrogen shows exactly 4 lines, it looks like, from this graph. Why 4? We'll see. Kyun 4? It's bugging you? Bugging me too. We'll see. Excited state. Gas excited state, also known as hot gas. बार बार लिख रहा हूँ because कभी-कभी टेस्ट में ये भी बोलते हैं hot gas, like what is hot gas? Excited state. Okay, cool. All right. So let's check out कि ये excited line और de-excited state कैसे आता है, ठीक है? तो इलेक्ट्रॉन ऊपर से नीचे गिरता है, higher state to lower state, and that is what leads to some sort of lines. Okay. So this is, say, the ground state. Okay. एक ऊपर, फिर दूसरा, फिर तीसरा, फिर चौथा, फिर पांचवा. You see, as it goes up, the energy difference keeps decreasing because of there is a square relationship. I don't know if you remember this. Energy is proportional to z square by n square. तो जैसे ही जो है z बढ़ता जाता है, E बढ़ता जाएगा. But if I keep the z constant, let's say z is constant, right? If I keep energy increasing n value, energy kind of like फर्क कम होता जाता है between the higher energy levels. Look, there is a more beautiful diagram for this, right? For hydrogen atom, where Z is equal to 1. Okay. At infinite distance, energy is 0. To take it from there and to take it to the ground state, n equal to 1, you get negative 13.6 electron volt. ये है ionization energy of hydrogen. Positive. अगर मैं इसी नंबर को positive कर दूं, that will become ionization energy. That's why I started the session with that question. Her question, everything is related. Okay, so please try and pay attention and read the NCERT and come if you haven't already done that. Okay, cool. ठीक है. And you will see that negative 13 becomes minus 3.4, minus 1.5, minus 0.85, minus 0.54. How did we get these numbers? Simple, na? Z square by n square. Put n equal to 2. That becomes minus 13.6 by 4. Put n equal to 3. That becomes minus 13.6 by 9. है ना? You will get this exact same number. Put n equal to 4. Let me remove that how, because मैं आपको already बता रहा हूँ. Negative 13.6 by 16. You see, that's how you get these values. यही तो मैं बोल रहा था. It is inversely proportional to n square. Hence, as you go up, these lines keep getting closer and closer and closer. Okay? Yes, Chintu sahab, exactly. This is for 26 बैच, 27 बैच, जिस बैच के लिए चाहिए कर लो. मैं 11th ग्रेड का एटॉमिक स्ट्रक्चर पढ़ा रहा हूँ, जेई के स्टूडेंट्स के लिए पढ़ा रहा हूँ, नीट के स्टूडेंट्स के लिए पढ़ा रहा हूँ, नेक्स्ट आईसर जो एग्जाम देना है दे लो, उसके लिए ये रेलेवेंट है. ठीक है, जेई एडवांस के लिए भी. Cool. So now let's try and understand यहां पे हो क्या रहा है. ये सब नंबर्स मैंने बता दिए. Now say I want to excite the electron from n equal to 1 to n equal to 2. How do I do that? Let me provide this much energy. ये जो नंबर लिखा है ना, I have to basically subtract minus 3.4 minus 13.6, which is equal to 10.2 electron volt. ये मैंने ऐसे क्यों लिखा? Because this is final minus initial. ठीक है? Don't worry about the negative signs. They'll figure themselves out. एक बार आप सही चीज लिखो, that negative 13.6 सही है, negative 3.4 सही है. Final energy क्या है? Negative 3.4. Initial energy क्या है? Minus 13.6. So to go to N2 from N1, I have to supply, because positive है, I have to supply plus 10.2 EV of energy. Did you follow this? चिंटू जी कल क्लास तो नहीं है, परसों क्लास होगी. फ्राइडे को देयर विल बी क्लास. Part 5 I will do on Tuesday most likely. Tuesday is the next class for this. Game साहब, Art, Lucy, are you here? महक, समझ में आ रहा है ये चीज? Yeah. I have to supply 10.2 electron volts to go from state 1 to state 2. Also, if the electron falls from state 2 to state 1, negative 10.2 electron volt is required. मतलब 10.2 electron volt is given away. समझ में आ रहा है? Is the same energy यार. When I go from 1 to 2 or 2 to 1. 1 to 2 I have to supply energy, 2 to 1 it will release energy. That's all. Let's put that in a proper equation. No, how many times will you remember these numbers? You don't have to remember these numbers. ये equation है n square. We will use inverse proportional n square. Let's do that. So for hydrogen, the change in energy, okay, now is going to be Hc by lambda or h nu, same thing. 2.18 in 10 power minus 18. This is for the first side, the first ground state, okay. E0, E1, जो भी है, n equal to 1. Times z square by this. What is this? n1 square, n2 square. ये क्या है? ये क्या है? What is this? Okay, right. What is n1, n2 square? n1, n2 क्या हो सकता है? Okay, cool. So let's think about it like this. I want to go from 1 to 2. If I want to go from 1 to 2, 1 by 1 minus 1 by 4 is equal to 3 by 4. This gives me a positive number. So ठीक है. N1 seems like the initial energy, initial state, and N2 seems like the final state. सही है ना? सही है ना? Right? No, you're absolutely right. Chintu, you're right. It is the shell, but it is initial कौन सा, final कौन सा, ये समझ लो ना. I want to go from N1 to N2. So I have to supply 10.2 electron volt of energy. We have just seen that. So N1 is initial, N2 is final. That's all. Aditya, I've gone to a lot of colleges, but I've graduated from one. इसकी कहानी आके डिस्कॉर्ड में बात करेंगे, नॉट हियर. ठीक है? नो, आई एम नॉट. शॉर्ट आंसर इज आई हैव नॉट गॉन टू एन आईआईटी टू स्टडी. आई हैव गॉन टू फेस. आईआईटी में फेस में गया हूं. दिस इज मी ऑन डिस्कॉर्ड एंड ऑन टेलीग्राम. वी विल चैट अबाउट माय एजुकेशनल देयर स्टफ देयर. If you want to know ranks, I'll tell you my ranks in exams. That I can tell you, but not here. Yeah, doesn't matter. If it matters to you, you come chat on me with on these places. There is a pinned thing. वहाँ पे जाके बात करना. Okay. So this is what you get over here. So energy ठीक है, but हम लोग जो स्पेक्ट्रोस्कोपी में यूजुअली टॉक अबाउट लैम्डा और द वेवलेंथ. Okay, that is more easier to talk about. Wavelength is easier to measure. Energy, ठीक है. Energy indirectly can be measured. Okay, so this whole thing is a constant, and what I get is 1 by lambda is some constant which is RH, Rydberg's constant times this, which is 1.1 into 10 power 7 meter inverse. ये जरूरी है because what I am doing now is 1 by lambda is going to be RH, which is again 1.1 into 10 power 7 मीटर इनवर्स z स्क्वायर बाय n स्क्वायर. ठीक है, कूल, दैट्स इट. तो लैम्डा हो जाएगा इसका उल्टा. ठीक है, लैम्डा विल बी इनवर्स ऑफ दिस. सो डोंट वरी अबाउट दिस. पहले ये दिखा रहा हूं. दिस इज आल्सो नोन एज न्यू बार और वेव नंबर, which means कि how many waves pass through in one wavelength. These are all concepts from physics you will learn later on. मैंने इसका आपको brief दिया था in the first session when we spoke of electromagnetic waves. You can check it out over there. I understand, got a little heavy. Anyway, ठीक है. For hydrogen atom, we will take z equal to 1. Now our life becomes easy. चलो z square चला गया. ठीक है. So hydrogen atom is so special that for each line a scientist takes credit for it. Lyman, n equal to 1. Balmer, n equal to, I'm not kidding, Paschen, n equal to 3. Brackett, n equal to 4. Fund, n equal to 5, and Humphrey, which is not really in your syllabus. Like last guy is, nobody asked this, right? But we'll tell you anyway. Okay, so what do you mean by n equal to 1? मतलब कि कहीं से भी अगर 1 पे गिर रहा है, we'll call it a Lyman series. और अगर 1 से कहीं पे भी जा रहा है, that is a Lyman series. Why यार? Why am I giving a series name? You'll see. It is beautiful. It's a crazy idea, and I just try to do with some simple maths. I'll show you what I mean. First spectral series, okay, it is found in the UV region. You're like, hi, UV? UV क्या है? Ultraviolet. Ultraviolet. मतलब less than usually 200 or 250 nanometer. Okay, इसको ultraviolet बोलते हैं. Because the visual range is between 350 to 750 nanometer. You can check out the actual values. Yeah, my chemistry is better than my physics, so I kind of remember it's between this. You can check it out, right? I think blue is around 300, 350, and red is around 750. Oh, this is the visual नहीं क्या बोलते हैं इसको? Visible range of wavelength. ठीक है? Visible range is in the second series. So in this case, I will fix the value of n1 to be equal to 1. That is my Lyman series. ठीक है? Not my, it's yours. सबका है. I don't have any this thing of it. Okay. Now this is very interesting. It's art and music. The H business has to do with Rydberg's constant when you're talking about in terms of this unit. There is another value of R which is in terms of energy. Okay, तो ये दोनों अलग-अलग यूनिट्स हैं. ठीक है. Sayam Anand here to troll us. Thank you, Sayam. I see you're from Discord. Random shout out just for that. फिर से मत करना भाई. पढ़ा रहा हूं मैं seriously. पढ़ लो. ठीक है. Lyman is simply 1 by RH because, okay, I skipped one small step. Okay. Wavelength of last line. What does this mean? Last line means that I am going by here to infinity. N1 equal to 1, N2 equal to infinity. What does this mean? This is the same as taking electron from 1 and pushing it out to infinity. मतलब सबसे ज़्यादा energy I will have to take to push electron from 1 to infinity. और सबसे ज़्यादा energy release होगी when it comes from infinity to 1. Do you understand this? देखो संयम जी भाग गए, मैसेज रिट्रैक्ट कर दिया. By the internet never forgets. मैडम मैंने तो बोल दिया है संयम तुम्हारा नाम लेके, तो इंटरनेट कभी नहीं फॉरगेट करेगा. तुम ट्रोल करोगे, हम भी करेंगे भाई. ठीक है. No, all fun and games. It's all right. So, did you understand this? What do I mean by last line? Wavelength of last line. Last line मतलब I take n equal to 1, n2 equal to infinity. मतलब बहुत दूर इलेक्ट्रॉन को फेंक दिया या फिर बहुत दूर से इलेक्ट्रॉन आया. ठीक है. That's the last line. अगर लास्ट लाइन इंफिनिटी हुई तो फर्स्ट लाइन क्या होगी? फर्स्ट लाइन विल बी 2 to 1, है ना? सेकेंड लाइन विल बी 3 to 1. लास्ट लाइन इंफिनिटी टू 1 मतलब 1 by 1 minus 1 by 2 square, 1 by 1 minus 1 by 3 square, and this is 1 by 1 minus 1 by 4 1 by infinity square. If you find out the energies of this, or basically 1 by lambda, you will get this to be 3 by 4 times RH. You will get this to be 8 by 9 times RH. Now, what is happening to lambda? 1 by lambda is increasing. मतलब lambda is decreasing. So lambda of infinity is lower than lambda of 2, lower than lambda of 1. So lambda 1 is the largest wavelength. Okay? समझ में आ रहा है? ध्यान से सुनो, ये सब मैथ्स है, ठीक है? Nothing else but just very simple arithmetic. Lambda 1 is the largest wavelength, smallest energy, largest wavelength, right? Largest wavelength, smallest energy. All right. I'm being a little repetitive because it's the first time you're probably hearing all these things. Okay. And lambda last is going to be the largest energy and smallest wavelength. Okay. That's it. That's it. So 13.6 और 10.2 के बीच में कोई भी अगर एनर्जी हुई, it will be in Lyman series. How do I know? Because N1 equal to 13.6 and 2 equal to 10 point something, right? 10.2. Cool. And so lambdas will be in between these two values. This 12,400 कहाँ से आया? I've done this in the last session. कर चुका हूँ. It's okay, dude. सही आपको ही चिल्ला है. Yeah, सही है. Cool. आओ पढ़ो. It's all right. Cool. Any doubts in this shortest and longest wavelength का concept? Please ask me if you have any doubts in the shortest and longest wavelength. Longest wavelength will be right next to each other. Yeah. 1 by 1 minus 1 by 4. That is the shortest. That is the longest wavelength. Right? Shortest will be 1 minus 1 by infinity. Okay? Cool? All right. Now I can do the same thing. Lambda max is first spectral line, lambda min is last spectral line. A lot of questions have been asked on this. Okay, in JEE, in NEET, in JEE advanced, sub jagah. And this whole thing is nu bar, which is wave number, which I've already told you, 1 by lambda है. ठीक है. Series limit मतलब last line को हम लोग series limit भी बोलते हैं जब n2 equal to infinity. Now, if I were to count कि कितने आ रहे हैं, तो all of them go to 1. These are the Lyman series. Similarly, I could have a second series. Second series है visible range में, Balmer series है. पहला था UV में. Why is it in UV? Because its wavelength is less than around 300 nanometer. Now this is going to be around 350 to 750 nanometer. Do the effort, please put in the effort, put in the numbers and you will see this, okay? Only first 4 lines for the hydrogen are in the visible region. इसलिए सिर्फ वो जो मैंने आपको दिखाया था ना, यहाँ पे 4 lines बनी थी. It was not random. This is slide number 64. No, let me show you. Go back to that slide जहाँ पे 4 lines थी. देखो, there are 4 lines because this is the real picture. This is the realistic, not real obviously. Realistic है, depiction है, yeah, of what actually happens. इसीलिए यहाँ पे 4 lines है. ठीक है? All right. 64. Let's go back to that. Cool. So for anything where N1 is equal to 2, you call it the Balmer series. Everything else is the same. And look at this. You don't go below this, okay? That is what Balmer series means. All right, a quick question. What is a line spectra? Characteristic of molecules, atoms, radicals, or none of these? Radicals. What are radicals? Have you studied what radicals are? We'll see. But what is a line spectra? Molecule, atom, radical, none of these. Well, molecule भी हो सकता है, atom भी हो सकता है. None of these radicals sound random. How do you differentiate molecule है या atom है? Well, in a way, each atom will contribute to the molecule. So I can say molecule also, but it's cause and effect, right? The atoms का spectra will cause you to see some molecule का कुछ representative thing, right? So it is atom itself. Okay, if this question ever comes to you, this is more interesting. What is the maximum wavelength line in the Lyman series of He plus ion? You want to try this question out, guys? Meg, Art, Chintu जी, आदित्य भाई साहब, IIT बनना है? बताओ, सवाल का जवाब बताओ. I'll show you a question that came from an IIT exam right after this. अभी संडे को जो एग्जाम हुआ था ना, let me open that up. I'll show you. I'm not even kidding. This came from the IIT exam. बहुत direct है भाई. Yeah. I'm opening that up. You guys please इसको try करो. Try this out, please. Where is the question? Where is the question? Where is the question? If you want, take a screenshot of this right now. Okay, I'm going to share the PowerPoint all about Nest. P2 template advanced. All right, that's the question right here. Okay, I know it looks a little messy, but here, take a screenshot. This is the JEE question. Kinetic energy associated with the electron in the first orbit of H atom, this, that, which of this is the highest, right? This is a literal question. And you can solve this just from the Bohr ideas जो मैंने आपको last session में पढ़ाया था. This came in the JEE paper, paper 2, question 1. All right. Just to show you guys कि यार आराम से पढ़ो, seriously पढ़ो, life will be good. Because if you guys do this properly, you're sorted. Really, you don't have to worry about anything else. Yeah. Anyway, I'm going to close this one out. We're back to this. Cancel. Discard. All right, cool. Back to this question. Maithili, thank you for the answer. Let's see. Let's see how things work out. Good job, Maithili. I think you are right. I think you are absolutely right. Let's see. So Lyman series क्या होती है? Final जो है end में n equal to 1. Okay? Or initially depends on how you look at it. n1 equal to 1, n2 equal to whatever else. ठीक है? Maximum wavelength. Maximum wavelength मतलब स्मॉलेस्ट एनर्जी मतलब n2 equal to 2. ठीक है? That is what you're going to have to do. So you have to decide, is it infinity or 2? If you put n in infinity, you will get shortest. ठीक है? Or the last line or shortest. This will be the largest. Convince yourself, put some numbers to it. I've already done that for you, right? 1 by 1 minus 1 by 4 is 1 by lambda. 1 by lambda is 3 by 4 RH, which means lambda is 4 by 3 RH. ठीक है? This is the longest. Right? Shortest would be 1 by lambda equal to just 1 times RH, which means lambda is equal to 1 by RH. इधर RH denominator में है. ठीक है? So this is the shortest, this is the longest. Put this number in here and very nicely you get 1 by 3R as the answer because 4 and 4 get cancelled out. Why? Because Z is going to be equal to 2. So Z square is equal to 4. So what you have left is 1 minus 1 by 4 becomes 3 by 4 times 4. 4 gets cancelled out. So 1 by lambda is equal to 3R. Lambda equal to 1 by 3R, which is excellent work, Mehak and Maithili. Good job. Good job. Oh, okay, Maithili. Thank you for joining in. I appreciate that. I appreciate that. एक और क्वेश्चन खत्म कर लेते हैं या पूरा टॉपिक ही आज एक शॉट में खत्म कर देंगे. If RH is a Rydberg constant for hydrogen atoms, the ratio of nu bar क्या है 1 by lambda of series limits are last lines. ठीक है? I have just taught you that. Of Balmer series of hydrogen atoms and Li2 plus is what? Please take a minute, try this question out. I think you will be able to do it. Yeah? Let's time it. Let's time it. Take 2 minutes. Timer 2 minutes. Take your time. Maithili, do you find this to be useful at all? Let me know. If you have any feedback how to make this better, please बताइएगा. Dishuji, I'm from Prayagraj. Can you try this question out? Dishu, कर रहे हो try? आगरा में क्या अच्छा मिलता है पेठा के अलावा बताओ. How do you start this question? Same thing here, right? 1 by lambda is RH times 1 by n1 square minus n by 1 by n2 square, which is, and series limit क्या होगा H plus H and Li2 plus के लिए? You have to basically go from 1 by 2 square. Balmer series मतलब n1 equal to 2, okay? Minus 1 by infinity. 1 by 2 square minus 1 by infinity. But Z होगा 1, यहाँ पे Z होगा 3 square, right? रुक 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 अरे भाई साहब ये तो बंद हो रहे हैं. बंद मत होइए. hold on. अरे खुल जा सिम से मेरे भाई. हाँ ठीक है. We are back. We didn't go anywhere. Don't worry. एक minute. I have to make a small teeny adjustment while you guys solve this question. I clicked some random thing and it almost closed out. Anyway, that's great, Maithili. But if you have any feedback on how to make this session better for you, let me know. I'll try my best to incorporate it. ठीक है. Into what? Into 3 square. Right? अरे यार, पेन साहब आ जाइए. That's 2 minutes now. I feel like time goes a little slowly here, huh, when you're on YouTube. Well, fast for me, slow when you're solving questions. For me, because I'm not solving, you're solving. Okay. So the ratio will be something times 9. There is no 4 in it. The only place that has 9 in this, you have to eliminate these two. You have to be careful about C and D. Okay. किस चीज का रेशियो निकालना है? Hydrogen versus Li. So you have to divide this by this. But I am getting, ठीक है, कुछ नहीं. Lambda का नहीं निकालना है, nu bar निकालना है. ठीक है, then we are good. Then it's simply going to be equal to 1 by 9, which is the answer. ठीक है, D should work out. D should be to work out. ज्ञान साहब, आपको आम खाना है कि गुठलियां गिननी है? आप खाइए आम. This is the best session you'll ever see on atomic structure. Make use of it. All right. So this is how you go ahead and do this, and this is the most difficult question you're going to face in anything based on this idea, right? Nothing more complicated than this. There's a different type of question where you sit and count the number of lines. We'll do that towards the end of the session. 5-7 minutes में उसको भी करेंगे. ठीक है? So these are the different series 1, 2, 3, 4, 5 and 6. तीसरी series, 3 and onwards, 3 and onwards are all in the infrared region. Same ही हो रहा है. ठीक है? यहाँ पे n you put as 3. That's it. Okay. Fourth is 4, 5 is 5. Not going to spend too much time on this. All of them are infrared. Okay. So to summarize all of this, this is what it basically looks like. Okay. This is the IR region. Okay. This is the visible region. And after this infrared. इसका क्या मतलब हुआ? जैसे ही N1 goes higher and higher and higher, you need to use infrared spectroscopy. At the starting of my session, I told you about IR and NMR spectroscopy. IR spectroscopy क्यों यूज करनी कि देखो यार N2 के बाद everything above the second क्या बोलते हैं energy state are all infrared. So you need IR spectroscopy. And as you go higher and higher, देखो energy level का distance is becoming smaller and smaller. The difference between this. इसलिए you need a more sensitive instrument, which is what this nuclear magnetic resonance NMR spectroscopy is all about. ये सब आपकी सिलेबस में नहीं है, but hey, एक दो शब्द एक्स्ट्रा बोलने से कुछ जुर्म थोड़ी हो जाएगा. In fact, maybe you'll be more interested in learning all this. Randomly bug नहीं कर रहे. This is the practical application of all of this. इसलिए atomic structure आपको पढ़ाया जाता है. A lot of students say, भाई क्यों पढ़ रहे हैं हम लोग atomic structure? क्योंकि if you ever get into any chemical lab, chemistry का और anything you're doing in a lab with spectroscopy or materials, you need to have an idea about all of these things. Okay, Maithili, I am doing chemical kinetics on the NEET channel, Maithili. So what I'm doing right now is मैं NEET channel पे 12th track कर रहा हूँ और JEE channel पे 11th का track कर रहा हूँ. So come and check it out. Yeah, part 5 is going to be on Tuesday, Maithili. You're able to solve questions of chemical bonding. Still, structure of atom is not very good. Okay. वैसे chemical bonding also I have great sessions bento links पे. You'll be good. Session 5 is going to be on Tuesday, Maithili. All right. Now let's try and figure out how do we count the number of lines. Okay. See, the maximum lines for the transition of 4 to 1. कैसे count करोगे? Okay. Just see, think about it. 4 to 1 कितने समय से होता है? एक तो मैं starting point is 4. So it will go 4 to 3, 4 to 2, 4 to 1. But it can have two lines that way also. Okay. After it goes to 4 to 3, that is the first thing. The second step can be it goes to 3 to 2. It doesn't go directly from 3 to 1. Okay. Not here. It goes from 3 to 2. And then the third step could be this. You see? So there are many different ways, permutation and combinations that you would take to go from 4 to 1. Like एक फास्ट लोकल होती है जो सही सीधे एक पॉइंट से दूसरे पॉइंट जाती है, दूसरी स्लो होती है जो हर स्टेशन पे रुकती जाती है. थिंक अ वर्ड लाइक दैट. ओके. And there are different permutation and combinations. You just have to account for all of these. Okay. Accounting for all of them. This was one idea. Like, let me use a different color. Okay. 1, say 2 and 3. That could be one set of things. Another thing could be what? Let's take this. Okay. पहला यहाँ पे चला गया. It goes from 4 to 2. And then it goes from 2 to 1, which is this right here again. So there are different ways of doing the same transition, but it could happen in multiple steps. And all of these have different lambda values because अलग सबकी energy value अलग हो जाएगी, है ना? अब डाल के देखो 4 to 3 4 to 3 would be this, right? That is this, no, we are doing 4 to 2 na, hara 4 to 2 hai, to 1 by 2 square minus 1 by 4 square, that is for this, okay? And 2 ka kya hai? 2 and 3 are the same. It's going to be 1 by 1 square minus 1 by 2 square. This is for 2, okay? And yellow wala hi 1 ka kya hoga? Yellow wala 1 ka kya hoga? It will be 1 by 4 square minus 1 by 3 square. So you see the numbers are different. So obviously the wavelength value is also going to be different. So these are different spectral lines, just proving to you, not just lines on that graph, they're actually here. You can find, you can do it from a different formula, or you can just calculate it also. Yeah, this is not a big deal. It's not that crazy. You can figure it out using this formula, right? It just comes from basic maths. आप इसको कोशिश करो, derive this formula yourself. It's not that complicated, and try it out. Okay. And for any particular series, you can do this. Okay. So I'll tell you what. Let's solve a couple of questions on this. Okay. There are some more. These are just extra things that you can check out. ये notes आपको मैं दे दूंगा, आप check कर सकते हो. ठीक है. So let's do this. If I want to count the number of spectral lines in Lyman series from the fourth shell, how do we count it? Lyman series matlab n equal to 1. Fourth shell matlab n equal to 4. So I've got three ways: 4 to 1, 3 to 1, and 2 to 1. Okay, that's three of them. Just three of them, because I'm going from fourth to this. But if I were to, maybe I can do more things. If I don't say Lyman series, if I say Lyman and Balmer series, agar main dono bolu, then I also have to account for 4 to 2. I have to account from 3 to 2. You see? So I'm counting plus 2. So get a little bit ingenious. Thoda bahut effort lagao life mein. This is it. Okay. Let's solve one or two questions on this idea and we'll call it a day. Okay. Ditch this. This is a straightforward question. Let's do this. No. Let's go to spectral lines wala sawal directly. Ye sab chill wale sawal hai. Let's talk about this one. Okay. Number of visible lines when an electron returns from fifth orbit to the ground state क्या होंगे? Yeah. Yeah. Maithili, can you check this out? Gyan Saab, हैं आप या भाग गए? Mehak, Dishu, can we do this? Can we solve this question? Number of visible lines when an electron returns from fifth orbit to ground state in H spectrum क्या है? अहमद जी, क्या हुआ? पढ़ा नहीं क्या आपने? 11th का दूसरा चैप्टर है. Which grade are you in? Are you in 10th? I understand the students come from 10th grade and maybe उनके लिए सब मुश्किल होगा. But this is 11th grade, boss. 11th grade का content चल रहा है. Varad, thank you, saying 4 and 3. Let's see. Varad, thank you for the quick answer. I'll just wait for maybe some of the other folks also to give me an answer here. But how do you do this? The basic idea is fifth say ground state. Fifth say ground state. Okay. So I've got 1, 2, 3, 4, 5. Not very well drawn lines. Let's draw them better. 1, 2, say 3, 4, and then 5. Okay. So 5 to 1 is 1. Then 5 to 2, and then 2 to 1. That's another. Then 5 to 3, and then 3 to 2, and then 3 to 1. This is getting a little cumbersome, isn't it? इसको काउंट करने में तो बहुत एफर्ट लग रहा है. ऐसा ही काउंट करें, कैसे करें? बट नहीं, हमको सिर्फ ग्राउंड स्टेट में डालना है. चलो इसको इग्नोर कर देते हैं. कैसे करें? तो सिर्फ एक ही लाइन दिख रही है. हाउ डू वी डू दिस क्वेश्चन? All right, Khader ji, welcome, welcome, welcome. Varad says 4 or 3. Varad, which one do you think? Chalo, let's draw these lines properly. Okay. Returns from fifth orbit to the ground state. How do we do this? How do we do this? Okay, एक चीज यहाँ लिखी है, visible lines. Oh, visible lines मतलब Balmer series. See, this is the hint over here. Balmer series मतलब n equal to 2. Remember, if you have, ये मैंने numbering थोड़ा अजीब सी लिखी है. This is n equal to 1. This is 2. Wow, how did I write this? Hold on. It's a funny thing, funny way of writing. Let me fix this right now. Give me a second. 128. Visible. Yes, 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 Varad. Thank you, thank you, thank you. Varad ने बहुत बढ़िया चीज spot की है, and I am completely on board with what Varad is saying. Let me quickly fix this amazing numbering जो मैंने यहाँ पे लिखी है life में, and then we will do this. 1, 2, 3, 4, 5, and 6. All right, cool. That should be good. I'm going to copy paste that here and just write that यहाँ पे, and then we'll call it a day. हो जाएगा, हो जाएगा, हो जाएगा. Chill है ये वाला तो हो जाएगा. ठीक है. One moment, please. I have another question after this, where I'm fixing the numbers. Because मैं सब जगह सवाल में numbers पता नहीं क्यों 0 के बाद 1 लिखा है. But that is 1. There is no 0, right? The first state is the first state. There is no 0th state. या खैर जल्दी में अजीब चीजें हो जाती हैं, नेवर माइंड। ओके कूल, सो आई नीड टू स्टिक टू n equal to 2, that's what the main idea is. Okay, okay, so I'm gonna go from 5 to 2, 4 to 2, 3 to 2, खत्म। यस मैथिली एग्जैक्टली। खादर जी आपको समझ में आ रहा है? बैग साहब, खादर बैग, या you go from 4 to 2, 3 to 2, and that's the answer. The answer is 3. That's it. Good job, everybody who figured this out. That was a very quick answer from you. Thank you for sharing this. Okay, answer is absolutely right. It's 3. Next one. In a sample of hydrogen atom, last question for the day, electrons make transitions from fifth excited state to ground state, producing all types of photons. The number of lines in the infrared region are what? I'm great, Zahir ji. How are you doing? Number of lines in the infrared region. How do you get number of lines in the infrared region? Infrared matlab anything greater than n equal to 2, which means 3, 4, and 5. 5 doesn't count. 3 and 4. That is the main hint here. Please try this. Sure, DK Saab. DK Saab, sure. Which one? That question or generally? In that past question or generally? What do you want an explanation on, DK? Follow this question maybe, and we'll get back to what your idea is. Okay. There are two things here that we are doing. Okay. We are trying to identify कि कितनी lines हैं. We have given some conditions. The condition in the last one was visible. मतलब कि visible मतलब n equal to 2. If this is going fast, please revise what I've done in the last 10 minutes. 15 minutes में मैं बता रहा था कि देखो जब when n is equal to 1, that n1 equal to 1, that is the Lyman series, that is the UV series. When n1 equal to 2, that's the Balmer series, visible series. When n1 equal to 3, 4, 5, 6, whatever, they are all infrared series. ठीक है? This is the other condition. Yeah, infrared पूछ रहा है. All types from 5. Okay, fifth. And this is another idea now. Another new idea. Fifth excited state. Fifth excited state matlab n equal to 6. Okay. This is ground state. This is first excited. ठीक है? 1, 2, 3, 4, 5, 6. 1, 2, 3. Okay, ठीक है. First excited. So this second excited. ठीक है? And this is going to be fifth excited. ठीक है? So I will go from 6 to 2, 5 to 2, 4 to 2, and 3 to 2. Correct? I'll have 4. Oh, रुको और भी होंगे. 4 तो सिर्फ यही हो गए. नहीं जहीर जी, maybe 6 is the correct answer. Varad, even I feel maybe a higher number, not 4. Because see, let's see. देखते हैं. 4 होगा कि 6 होगा? आपको क्या लगता है? 6 कैसे? जहीर को लग रहा है 4, हमको भी 4 लग रहा है. 6 कैसे हो गया? थोड़ा बताओ. 6 कैसे हो गया? बताओ. देखो, why only to 2? Ground state जाना है ना. Why are we going to this? We have to go to 3, sorry, not 2. 1, 6, क्या कर रहे हैं? 6 to 3, 5 to 3, 4 to 3. Sorry, मैंने लाइन थोड़ी अजीब सी ड्रॉ करी. तो 3 यहाँ पे, only 3 over here. Okay. But I also have 6 to 5. I also have 5 to 4. Okay. So 3 and 2, 5 हो गए. और भी बची है क्या? We can do one more. I think we can do one more. 6 to 5, 5 to 4, 4 to 3. Varad and Maithili saying 4. नहीं, मुझे तो 5 already दिख गई. 6 कैसे है? Varad, 6, can you help me with 6? I feel too that the answer is 6, but how is it 6? थोड़ा help करो मुझे. Okay. Let's start from the scratch. We have 1, 2, 3, 4, 5, and 6. So this number is the 6th. Okay. So let's go all the way from 6, all from infrared. 6 to 4, 6 to 5, 6 to 3, 6 to 4, 6 to 3. So starting from 6, there are 3 lines. Okay. Now starting from 5 now, 5 to 4, 5 to 3, there are 2 lines. Okay. Starting from 5, there are 2 lines. Starting from 4, there is 1 line. Okay. Starting from 4, there is 1 line. Hence, the answer is 3 plus 2 plus 1. 6. 6 ही तो है. मैथिली कंफ्यूज तो नहीं होना है. अगर इसमें कंफ्यूज हो गए तो पेपर में क्या करोगे? There is no confusion. You have to do things carefully. Now you decide how you want to do it. है ना? Good job, Varad, on sticking to your guns. ये सबसे जरूरी चीज यही है ना. एग्जाम में चक्कर ये है कि you may know all the theory in life, but एग्जाम में प्रेशर के समय you have to be able to deal with it. You have to follow process. तो आपने देखा, जैसे मैंने शुरुआत से किया, that was not the right way to do it. मैं कुछ भी लाइन ड्रॉ कर रहा था without any sort of process to it. What is the process? Start from 6, then start from 5, then start from 4. ठीक है? This way you will miss it out. अगर आप चाहो तो फॉर्मूला यूज करना चाहते हो कर लो यार, मैं तो नहीं रोक रहा हूं आपको फॉर्मूला यूज करने से, बट आई डोंट लाइक यूजिंग रैंडम फॉर्मूले. ठीक है? वी कैन डू फ्रॉम फर्स्ट प्रिंसिपल्स. या ऑलराइट. जहीर जी, रेडॉक्स रिएक्शन के मेरे सेशंस हैं, आप देख लेना. देयर आर 4 or 5 सेशंस, दे आर वंडरफुल वंस. आई हैव टॉट इट वेरी वेरी वेल बिकॉज मैंने फर्स्ट प्रिंसिपल से पढ़ा है, and I've taught a little bit more than what NEET requires, but it's been done nicely. You can check out the bento links. DK ji, ठीक है. This was the last question I had for you, and the answer of this question is going to be 6, and you guys have figured it out, which is lovely. Now let me address DK's question, right? Maithili, are you good now? Not confused? You're good, right? Can you explain a bit about possible transitions that electron can make in general? DK साहब, ठीक है, आप बोलते हैं तो फिर से कर लेंगे. Let's keep it short though, because I've already explained this. Here, DK, this is the graph that explains all the possible transitions. ठीक है? Now, ये जो मैंने किया, I focus on the starting line, right? What usually is done, you focus on the ending line. But ये ending line वाला focus ना दिमाग में करना थोड़ा मुश्किल होता है मेरे लिए. मेरे लिए starting line is easier. But in most textbooks everywhere, you will see this sort of thing. Ending line जो है, that is important to them because that is they're giving you the series. So all of these are in the UV series. ठीक है, यहाँ पे मैंने पता नहीं क्यों IR लिख दिया था. UV series है Lyman series, which means कि these are all the possible transitions that end up at n equal to 1. Okay, this is the ending point, end point. And here n equal to 2, and here n equal to 3, 4, and 5. These are all the possible transitions. That's it. As simple as that, DK. What was your doubt again? These are all the possible transitions an electron can make in general, as you asked, right? When n equal to 1, 2, or 3. Now, when you put a condition to it, condition ये डाली है, the questions we saw had conditions to them. What is the first question we saw that has condition to it? इसमें condition थी कि भाई हमको चाहिए number of visible lines. 2 condition है. एक तो 5th orbit से गिर रहा है ground state. So it is going from 1, 2, 3, 4, 5. It is going from here to ground state. But I want to see visible lines. So I have put a condition. Oh, that's why we say कि चलो 2 तक ही रुक जाते हैं, right? This, and this. So 2 तक ही रुक जाते हैं from 5. That was a condition. 2 तक ही रुक जाते हैं. ठीक है? This is how you solve this question. So depending on the question you have to put a little bit of extra effort and figure out condition क्या है. इस वाले सवाल में condition 3 कि 5th excited state मतलब n equal to 6 to ground state and all in infrared. Infrared का क्या condition है? Infrared is n is greater than 2, which means n is equal to 3, n equal to 4, n equal to 5. This was the other condition. So these are sort of boundary conditions. Broadly तो आप समझ गए कि electron transitions कैसे होते हैं. Conditions ये हैं, IR हो गया, UV हो गया, visible हो गया. That's it. You're done. You're most welcome, DK. Deepak, Varad, thank you so much for checking it out. And if you have any suggestions on how to make things better, बताओ. I'll try my best to incorporate it. Okay. Bye, everybody. Good night. Good night. All right. हाँ, of course, Zahir, that's the goal. मैं already कर चुका हूँ, बहुत बार कर चुका हूँ complete, but आपके लिए पहली बार लग रहा है. We'll do it together. चलो, see you. Bye. Good night, everybody. Have a good one. See you all. Tata. Bye. अगला सेशन ट्यूसडे को है. By the way, I'm doing the 12th sessions on the NEET channel and the 11th sessions on the JEE channel. But the content is the same. So whether you're a JEE student, NEET student, कहीं पे भी आप दोनों चीज देख सकते हो. मैं ट्यूटोरियल सेशन दोनों के अलग अलग करूंगा जब 2 चैप्टर खत्म हो जाए, टू हेल्प यू फिगर आउट थिंग्स स्पेसिफिक फॉर NEET, स्पेसिफिक फॉर JEE. ठीक है? बाय. सी यू ऑल. गुड नाइट.